Hello guys, welcome back to my channel. As you are aware, in our previous videos we are continuing with designing of the items found in this commercial kitchen layout. It's a simple layout that we have been working on, and yes, we have made a couple of steps, and we are in the pastry preparation area. And today we are going to be designing the knee-operated hand wash basin. We have one at the pastry preparation area, and we have another at the entrance of the goods receiving area. So we will be doing the hand wash, and the hand wash looks like this, right? The overall size is 500 by 400, and a bowl with a guard on top, a stainless steel guard on the top. This panel is fixed. On the other side there is a panel fixed. The back is open because of the drainage, the bottle traps, and the pipe water connections and all that. And we have a knee operated tap and a swing panel. This is where you press with your knee on this panel, which in turn presses the tap, and you get water on the tap spout, right? So without much ado, and as you can see, most of this is sheet metal, right? Sheet metal, and just a few weldments here on this structure, this square tube structure, which is basically for the purposes of mounting the tap and also reinforcing the panels. Right, so let us get right into it, and we are going to start with the top, which is 500 by 400. So you open your SolidWorks, go to new file, part, okay, then go to the top plane, new sketch, center rectangle from the origin, then in smart dimension, this is 500 by 400, and that is the overall size of the hand wash basin. So exit the sketch. That will help us give relationship to our sketch. So go back to the top plane again, feature, reference geometry plane. You can offset it by 100 or 200, or even not offset at all. From the new plane we do our new sketch, center rectangle, don't snap it at the center. In any case, we are going to give it relationship, basing it on the first sketch. So from this edge to the outer edge is 50 millimeter. The three sides, this edge, 50, this edge, and this edge, 50. And at the back, that is where we have our upstand, it's 15 millimeter. 15 millimeter. Yeah, that sketch is good and properly defined, fully defined. Even as you can see, the sketch is fully defined. You go to sheet metal, base flange, and the material thickness is 1.5. K factor here, everything remains the same. And for those who want to know, is that most of the time sinks we do stainless steel 3 or 4 1.5 millimeter. you can go ahead and hide this plane. Right, so we have base flange, not base flange but edge flange at the back, and this we give it an upstand of 50 millimeter. 50 millimeter, that is good. Then we go to tab, and we are tabbing it on that upstand. You go to corner rectangle, you snap it at this edge, that one, then we give it relationship, this and the top, make it collinear relationship, this line and this edge, make it vertical or coincident relationship. That's pretty much okay. Yeah, you can do the tab and you mirror it, or you just do a construction line there and mirror entities. Entity to mirror is this rectangle, and we mirror about the construction line. Then you exit the sketch. Make sure to merge the results, so that when you are doing your flat pattern, it will be one and the same thing, right? See, one and the same thing. Then we do edge flange on this side, edge flange on the three sides. You can also do a mitre joint if you want, mitre flange if you want, or edge flange. Degree here should be 30, right, and the end condition 20 millimeter. That's okay. Then you do corner, closed corner. Make sure it's a butt type. Choose this and this, or you can take one, then you mirror the other. Okay, and that is done. You do edge flange again, this edge flange, edge flange, edge flange, and make it parallel to this face, right? That's pretty much it. You click OK, then you edit the sketch, edit this sketch, and make the relationship between that and the initial sketch, make them collinear. Yeah, so it has been snapped to this edge, to the overall size. Now you do another edge flange at the back, click OK, edit sketch, make this line and the back line here of the first sketch, make it collinear relationship. That's okay. Then edge flange again, 15 millimeter, and condition 15 millimeter. That's okay. Go to corner again, closed corner, but 0.1 is the gap. This delete this face. So no, I have deleted the wrong face. Clear selection. We need this face and this face, and on the other side this face and this face. Right click, there we go. Then you do another edge flange. It is better to do a sketch for a miter so that you might save some time rather than doing edge flanges here and there. And this should be actually 40 is okay. Then finally we have edge flange at the bottom there, which is 15 millimeter. Edge flange in this direction, edge flange, edge flange, and condition is 15 millimeter. That bend there gives the sink some strength, and also to avoid sharp edge. I did the first sketch. Our top is ready. Flat pattern. Flat pattern is good, right? Flat pattern is good, very good. The gap is not that big. When you are doing your welding, you won't have any issues. Your welding will be right here through. Then there will be another welding here, this side also, and that. Yeah. So go ahead and save it, and we are saving it in PP4. I have a folder known as PP4 part number 1, which is PP4 top. Then we create a new sketch for the cutout of the bowl. Center rectangle. Then we smart dimension from this edge to this, give it 30 millimeter. This to this 30, this to this also 30. At the back you can keep it at 50. millimeter. Yeah, that's okay, that's nice. The reason why we are doing 50 is for the positioning of the tap. You want some space. Some people might do the tap here, others might do it at the center or at the other head. So you fillet the sketch and fillet radius 30, fillet all the corners. Yeah, before we make the cutout, let us get the dimension of the bowl. The bowl will be, that is 254 by 339, 340, 254 by 340, right? 254 by 340. Then go to feature, extrude and cut, linked thickness. That's pretty much it. That's okay. You can save. You can even go to material and assign it a material, which is metal, steel. To go for polished steel, right click, add to material to part. Yes, our top is done. We go to file, new, part, click OK, and go to the top, new sketch, center rectangle, snap it at the origin, smart dimension. This is 254 by 340. Does our bar really look like that? We will go back and confirm. Then we fillet still at 30. The fillet radius is 30. I highly doubt whether I got my measurements right, but the beauty with SolidWorks is that you always can edit the sketch. Yeah, feature we are going to we didn't exit the fillet. Extrude. The height of the bowl is 100mm deep, or even 150 if you want. Depends with the size of the bowl that you are having. Most of these bowls we normally do imported, we don't fabricate. And the people who are privileged to have pressing machines, you just need to press it so that you may have a very smooth, very nice, beautiful bowl. Let us first confirm the cutout. Extrude and cut, sketch. We edit sketch because it doesn't look nice to me. It doesn't look like they are green. It is 254 by 340. That's okay. 254 by 340. Feels like it is still the same thing. It's only that I gave the dimension in yeah, this is the one which should be 254. I don't want to go and rotate by 340. I don't want to rotate. Yeah. Then shell your extrude, and the thickness should be 1.5mm. And your cutout is good. Your bowl is good. Make a hole for the drainage. Diameter of the hole is 50mm. 2 inch. Using a bottle trap of 2 inch, that is 50mm. Go to feature, extrude and cut, link to thickness, or if you do it 100, it will make your cutout. Yeah, there you go. Go ahead and save this. For a hand wash, you don't necessarily have to have this kind of bowl. I said, well, on another video I will do a bowl whereby we will get the flat pattern. With this you can't get flat pattern. We'll do a bowl and get the flat pattern for the purposes of putting in the CNC machine, the cutting, a fabricated bowl. For those people who don't have resources to go for a pressed bowl, we will do a sketch, we will do a bowl which you can fabricate a drawing for the same. Yeah, so we save it as part number 2, PP4 bowl. And from that, as you are aware, when I have 2 parts, I normally start my assembly right away. So new assembly, and the first part is the top, and this insert part, the part to insert here is the bowl. Then a mat. Don't have to do a lot of matting, you can go for this corner mats coincidentally with this because of the fillet. Where that point your bowl is set and in position. Now you will do your welding round here, and polishing won't be hard to do that part. Now with that done, go ahead and save all. We call it PP4 hand wash basin. Right, now we want to do the structure for, no, let us first do the panels, the side panels, and with that let us evaluate and try to get this dimension from this face to back here. The normal distance is 369. The normal distance is 369, so our panel should be right around 368, 365 there. So we go to new file, a new part, click OK, and we go for the right plane, new sketch, center rectangle. The length we have seen to be 363. It was 364. I don't know. 365. Let us do 365. We are going to confirm it, and the height should be 320. Yeah, sheet metal, base flange. The side panels can be of 1 millimeter thickness. The anchor, no, it's just for beauty and hiding the tap connection and the bottle trap, the drainage connection, edge flange, the 4 corners. You only need 1 edge flange, which is about 20 or 15 millimeter. 15 millimeter is ideal. And condition 15. Right click, save as part number 3, side PP4, side panel, save. We go back to our assembly, insert components. Component to insert is side panel, met this top part, mates with this, click OK, this face to this edge, this face, click OK, and this face of the front mates with this edge of this bend, this face, click OK, defined well. Our sketch, our initial sketch was good for the side panel. Exit the met and go for the top, expand the top, go for the right plane, mirror components, component to mirror here is the side panel. Yeah, there you go. Now we need to do the swing panel, right? The swing panel. Now what you are going to do to the swing panel, let us first do the swing panel. We go to evaluate, measure from this edge to this edge to this face. Normal distance is 438, so we'll do 436. We want there to be some gap. New file, new part, and it's the front plane, new sketch, center rectangle. We have seen this to be 4. I keep forgetting 4. I keep forgetting, I don't know why. He said it was. Let's evaluate again. We do it once and follow this, and this. 438. So we said 436. Where did I get 460 from? 36, 35 actually, because when you do the edge, this should be 320 plus 20 millimeter, 330, 340, 340. I'll explain why we have done it 340. And sheet metal base flange 1 millimeter, that's okay. Yeah. And edge flange all around, and condition blind. The blind is of 20 millimeter. 20 millimeter, which can do 25. Then edge flange again, gotta give it some little strength, little bit of more strength, because it will be swinging every now and then. Anybody goes to wash their hands, yeah, you don't want the panel to deform quite easily. And condition blind, size is 15 millimeter. That's pretty good, and you can get your flat pattern out of this. Save a DXF, feed it on a CNC, and you get your cutouts really good. Save this as part number 4, which is PP4 swing panel. Yeah, we need to do a cutout here. New sketch, circle, and you snap it at the center of this face. Diameter depends with the rod that you're going to use. In this case, we are going to use a rod of 8 millimeters, so we can do a 9. Diameter of the hole should be 9. Then from this edge to the center, we keep it 15 millimeter. Yeah, and it is at the center, so it is fully defined. And you go extrude and cut through hole. You cut through hole, so that you may cut through hole. You cut this face and the other face. That's nice. Yeah. Now, why did we do that? Where is the rod going to be? The rod will be welded right on this face, and we need to do a little bit of, yeah, let us take this open. We need to, this panel looks like this, so we need a new sketch here. Normal, circle, diameter of the circle is 8. It's just to show that this is a rod that will be welded, and from the center to this, remember the side panel, the swing panel has that bend of 20 millimeter. So from that center, and you want the side panel and the front swing panel to flush, so this, you give it what, 10 millimeter? No, it's 20. That should be 20. Is it 20 from the center? You can do 20, we see. Am I thinking well? 20 then 10? No, it should be 10. 10, 5. I don't know. What do you think? 15? If it is 20, so it would be recessed with 10. So this should be what? 10? I think it's 10. 10, and from here to here to the outer part, what's going on here? 10, 8. We want smart dimension from here, smart dimension here to here should be, we gave it 20 more, give it 15. Well, when we met it, we will see how it will be like. Feature extrude and extrude it at around 20 millimeter. It is the length of that. I hope I'm doing the right thing. You see, these are the things that you come to do at the end when it's just a road and you fix it there and do the welding. It doesn't interfere with the flat pattern, with the DXF. This is a road that you'll just do a small welding around there. So yeah, once you have your panel, the exact position of the rod, you will get it with this swing panel. After mirroring, where is the other rod? The other rod went to the back, so we might be forced to change this panel. Met concentric. This and the rod should be concentric. Yeah, our panel, we are going to reduce it. Then we go for advanced met, and we go for width. That is between this and this, should be between this and this. Yeah. Do we have a gap to allow the panel to swing? Now we will edit that sketch and open, give it a little bit of gap, so we do 433 by 320, so that may flash with the bottom of the other side panels. Save. Might look like it's trial and error. Yeah, it is flashing right now. It is flashing. It is good, and the gap is good. The panel can swing quite well. Yeah. So this is how it works. You press with your knee, hits the top, you get water on the sprout, and once you release it, the panel goes back to its original position, and you want your panel to be flashing completely with the front panel, with the side panel, right? We didn't do a cutout for the top, so sketch on that face, do a hole 21 millimeter. Most tops have a diameter of 20. We do 21. Don't want to damage the threads. Smart dimension from the edge to the center, you can keep it 30, and from this to this edge, the center, give it 25. I want some space for the washer. feature, extrude and cut, link to thickness. That's good. You have the opening for the tab. Save. Now we want to do the we want to do the structure for holding the tab. Yes, that should be between this panel. Let us evaluate between that panel and that panel. The normal distance is 6. The normal distance is 468, and the height should be right around 320, not 320. Do it. You want it to be somewhere. You want your tab to be somewhere here. So what should be the total height? Yeah, the total height can be 320, and to give, let us do the sketch. We go to file, new file, part, click OK, and go for front. Is it front? 3D sketch. Line. Let us start the line from the origin. Here, tab to make snap it on the ZX axis or the Z axis. Another line there, and another one here. Tab. Now we are going to make the relationship between this line and this one should be parallel relationship, and this line and this line, they should be parallel and equal. This line and this one, they also need to be parallel and equal. Yeah, so we give smart dimension. This should be 320, 318, slightly shorter than the panels. Are these lines equal? Is this 318 also? Yes, this is 318. This we saw to be. Let me go for 460. I will confirm, then do the deduction, and this we're also going to confirm from our tape measure. Yeah, before we go for the weldments, let us confirm those dimensions. here to here, normal distance 468. 468 minus 20, 448, 445. Let's make that 445. Now sketch here. 445, 445. We subtracted 20 because it's a weldment, and it being a weldment, you know the drill. Yeah. From the size of this panel, from this face to this back, to the back, is 376. 376 minus 20, you get 356. And you want your panel to swing, say that is that, plus the top is inclined at an angle. So 370, you can deduct 100, you get 270, right? 270. Let us do going to the back. You see the top is inclined at an angle, and this square tube is inside by some distance. These are the things that I tell you. The size, the design of the top that you're having will give you the exact size of this tube. So mine might not be, you might not follow this sketch completely. It is just to give you an idea of how to go about this thing. We got weldments. We didn't exit the sketch. Exit the sketch. Go to weldment, structural member, isotube of 2 millimeter by 20 by 20. The thickness 1.5 millimeter would be good. In my square tube configuration, I don't have that size. So the first group is this and this, this and this. The new group, this and this. Then another group, new group, this. Then finally new group, this. We are set. Right click, hide the 3D sketch. Yeah, so your top will be sitting on top of this square tube. It also the design of the top that you are using again will determine whether you are going to add some bracket, because the top has to be mounted. It has to be mounted with bolts and nuts. It has to be removable. Right, that being the case, we save it as part number 5 and call it PP4 top structure, top mounting bracket, save. Now we go to our assembly. Insert component. Component to insert is this met, and first we are going to met the bottom to this face. You'll do a bit of welding there. Then you go for width, advanced met, this width, this and this, between this panel and this panel, That's pretty much okay. Then you go for distance. Here you give it, say, 100 millimeter, or yeah, 100 millimeter. Let's do 100 millimeter. 100. That is between. It has to be recessed from the inside. That is that, and this face. Sure. We are going to bring in the top. If need be, we will head it, and in any case, this part of the square tube should not protrude, should not be longer than the panel. Okay, so let us insert our tap. I had pre-designed a tap which didn't exactly look, it was something that I did. Yeah, it's not a real tap. Knee operated tap. Now which one is which? Which is which? Knee operated tap. I think this is it. Yes. Now you see my tap, and why we are offsetting it is because of this degree, because this is the tap, this is the pressing mechanism. The panel, press this, go in this direction. I'm not sure, when I was doing my assembly I should have shown you this, but we will get a real tap and do design of that tap following the exact dimensions and all that. This was just a representation of the tap, right? So you don't worry about that. Now let us do our matting. The first mat we will do is, I don't know whether I have this. Let me see, tap. That right plane? Is that right plane running at the center? I don't think so. Let me just clear that and do this bottom to this face, then we can go for and we don't need to change that to this setting. Now let us go for advanced mat width. So this face and this sits between this. I need to sit exactly at the center of the square tube, and this, yeah, that's okay. Then we also do width again. We did a mistake. The tap should be sitting up here, not down there. I'm not sure whether we will be in position to edit that. This and this. To be between this and it to be at the center of that structure, and that. Click OK. Now let us try to change something here. Met. Coincident. Yes, this one. We edit. It is the face of the top, and this is the one that we are supposed to delete. It is that and this. And this. Yeah, the top should be sitting up there. not below there. Yes, that's about it. Now let's see the gap is way too big. We will also edit. Let us take this and evaluate measure between this, the normal distance between that and this. Normal distance is 96, and you ideally need the gap to be like 20 millimeter. You press this panel here. You need it to touch the tap, right? So you give it a gap of 20 millimeter. So from 96 minus 20, that should be around 76. So in our mates, there is distance. This distance, we edit it and make it smaller by 76. So this comes to 24. Not 24. We have given it what was it supposed to be? It was, at that point it was 76 and we needed it to be 20, so we should have done it at 56. Is it 56? Let us first exit, then we give this panel some transparency, change transparency so that we may see. Also this, change transparency. Yeah, then we go for the side and see. Yeah, there is hardly any gap there, so we can reduce that width, not width but distance. Where is that distance? Distance, edit. We edit, it is at 56. Can we do it at 66? It looks, yeah, remember this panel is 20 millimeters. That gap looks okay to me. Sure, it looks okay to me. Here it is flashing, and I feel like the hand wash is good. So you press on this panel, swing panel, it presses the tap. The tap is connected. There is some connection here from the sprout. The outlet of the tap is connected. There is the inlet from the water source. It should be somewhere under here, or it can be here. You connect that from this water source, then this is connected to the sprout of the tap here. Once you press this, you get your water. That mechanism, your plumber will help you with that, right? So this is pretty much it. The only thing that is remaining to do here is to put a mounting bracket, which we are not going to do. Depends with how you will do your mounting. The only challenge with that bracket, you have to mount the sink first before you insert this. Remember, this is just you insert it. The swing panel is not welded anywhere because it's supposed to be removable when you want to do servicing to your tap. And also this connection of the water has to be done on the side. So the first thing is mount your sink, mount your tap, mount your sink, then do your connection put your swing panel, right? This method might not be the best for supporting your swing panel. Yeah, you can come up with an easier mechanism, because you don't want again to have issues fixing this panel here. And as you can see, the gap is very small, because you don't want again to give a big gap here, have issues, right? So that is pretty much it. Mine is to give you fabricators an overall idea of how to go about these things. You have a better way, you can leave a comment down there, help me also understand. But again, for us guys who do fabrications, these things, you get ideas as you're doing the fabrication. For the minor things is how to fix this panel, how to fix the tap, how to put a mounting bracket. These are the nitty-gritty things that you get as you do the fabrication or on site. You get ideas, they just pop in and you're good. There is one more thing that we have not done, and it is this bracket here. This bracket we have not, the guard. So let us go ahead and do it real quick. Height of it is 260. Don't ask me why 260. So that guard starts from here, from this edge to this back. Normal distance is 386, so we can do 384. Go to file, a new part, click OK, and go to the right plane, new sketch, center rectangle, to 60, 260 by 384, 384. Yeah, then you do maybe there is something that we didn't do there, but still no problem. How are we supposed to do it? From this to this? Yes. Then this and this, make it tangent. Is that right? This and this will become a tangent? I don't think so. This and this can't be. Delete. No, over. That is not right. Happened there. Okay, I needed to delete this only. So our arc should start from here to here. Yeah. Then we can make this and this tangent. Exactly. That is good. Then this line and this line, we make it construction, and we complete this one here, behind here. Then you go to sheet metal, base flange, 1 millimeter. That's okay. Yes, edge flange. That edge flange should be 500. 500. Click OK. Then edge flange again, and don't keep end condition up to vertex. That is that vertex. Click OK and do sketch here. New sketch, convert entities, convert this arc. Did we convert it? Convert entities. We need that arc. Yes. Should have also done convert entities, and we convert this and this. Convert entities, this, whatever. I don't know. Make it construction geometry. Yeah. We want to extrude and cut this. So this line up there. Extrude and cut. Yeah, link to thickness. That's good. Then we have an edge flange. Sheet metal edge flange at the bottom here. 10-15 millimeter. millimeter be good. Yeah, we have an issue there. I don't know what issue we are having. Don't know why we have an issue there. For that edge flange, we cancelled. Edge flange. Edge flange. Edge flange. Why is it giving us issue? Yes, it shouldn't give us issues. Save it as PP4 guard. SolidWorks PP4 part number 6. PP4 guard. It's not necessary, right? But also it is kind of necessary, because you see the casing is very small, and the bowl is also very shallow. Water might be splashing right, left and center, so it is important to have that guard. Insert component to insert this guard, and you go and go ahead and met this to this. Nice one. And backside to that. Good one. Remember we didn't start with this edge flange, so we cannot met the planes, so we go for width. Advanced met width. This face and this face should be between this and this. Hey, going on, sorry, this, what is going on? This, no, what are we mating? Standard mate, coincident. Just start the mate again. Mate this to this. Yes. Then we go for advanced mate. width, this face, and this face, and this centered, right? And this. Yeah, but I feel like something is not right there. 500, we should have given it a small, this edge flange here, we should make it like 505. This, that edge flange, this edge flange here, we headed it from 500 to 505. 505. Let's see whether change has been effected. Yes. Yeah. Do we have a gap? You don't want a gap here. You don't want there to be a big gap. There is a big, huge gap here. You don't want that gap. Right? So 542. That is a big gap. Don't want there to be and hiding for that. This is why I switched from doing my drawings with AutoCAD to doing with SolidWorks, because with SolidWorks you can do the assembly and all that, and in case you see something that you don't like, it's always easy to edit. But again, when we are doing our fabrications, one of the things that we normally do is before you cut like this part, you do your top, you do your top, and the bowl, do the welding. Before cutting these panels, you confirm the size, because you know there might be some discrepancies between the guy who is doing the assembly, the welding, and the guy who is doing the bending. They might not follow the marks accurately, because this is bending is done by a human being and a machine, and sometimes the bending tool might not exactly hit at the bending mark, right? So 2-3 millimeters might be lost or gained in the in the process of bending and welding. So what we normally do is we do the top, do the bowl, do the welding for that. The drawings and the DXF files are ready. Then you confirm, you take this measurement, is it in agreement with the panel, with what you are intending to cut. If it is in agreement, you go ahead and cut the panels. The swing panel will come in later once you've done the welding of the side panels. Then you confirm again the measurements, you cut this, right? Once the bottom part is standing, once the whole sink is standing, the hand wash basin is standing, you confirm these dimensions, because as you can see, for this is one part. Get the flat pattern of this. There is no welding. These are bent, these are bent, the bottom there bends. The welding will be right under here. You want it to be very neat. So it might feel like it's a tedious process, or you know, and maybe time consuming. You are cutting this part, you are cutting this part first, then this part, do the welding. The guy on the CNC machine waits for you to do the welding or something like that. Then you come again, confirm these parts, go ahead and cut, do the bending. It is better you lose a few minutes than to lose an expensive work material, because if you cut this part and it is small, it won't fit. What do you do to it? You can't weld and polish. It will look ugly. That work piece goes to waste. So it is better you measure and reconfirm as many times as you can, but only make your cut once. highly recommended, right? Highly recommended. That in any case, when you are doing your fabrication, it's not like you are doing this work alone. Yeah, as they are doing the assembly of the welding of the top and the bowl, and your CNC guy is cutting, say, some worktop or some bain-marie top, you know. And again, also the thickness of the materials are different. So you are cutting the 1.5, the top and the bowl, remove that material, feed in material of 1 millimeter. Yeah, so a few minutes waiting here and there won't hurt, other than you losing money in form of material, because you either made a big, the workpiece was big or was small. Yeah, in the computer and in assembling SolidWorks, everything looks perfect, but when you are actually doing the fabrication, that is where you will realize some millimeters here and there lost or gained, right? So you take your time, do your work well. But if you have vast experience with these things, hey, if you can do it once, why not? As for me, I would rather measure as many times as possible. Once I do my cutting, I'm 100% sure I ain't wasting no material. Alright, with that said, thank you so much for your time. Have a lovely day. We shall meet on our next tutorial, and we will go straight to the pot wash area, right? We did the waste bin on casters. It's the same as the one on the goods receiving, so we are not going to do that. We have a worktop here, we have a triple ball here. The triple ball is not different from a single ball sink. It's only that the bowls and the length, the size is what will be changing. So we will do one table here and this sink, and the worktop will cater for all the other worktops. We are not going to repeat worktops. Then we can come up here and do the pre-rinsing. The pre-rinsing is slightly different from the pre-rinse sink is different from any other normal sink, and the run-out table is different from the the normal worktops. These are racks. They are completely the same as, they are totally the same as the others for the dry storage. Then we will not spend a lot of time in the pot wash area and the dishwash area, and also in the food prep, meat prep and veg prep, because this is just a sink and this is another sink. Here we have a worktop. Of course, we have an under-counter fridge someplace, so we won't spend a lot of time here. We will spend some time at the savory area. We have a bain-marie, we have a hot cupboard with a hot pass, also the bain-marie with overshave and hot pass and all that. Then we will come and camp here, doing the cooking range, and I think the layout will be done. Right, so thanks so much for your time. See you guys on our next video.